Hi, this video is part of a series in which I learn about programming a retro video game on the Commodore 64 in assembly. The code I'm using is from the game Supernatural, written by Georg Rottensteiner. You may also know the game as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video.
Yeah, welcome. Step 8. Step 8. We are doing, it's not such a big step, but I figured, I didn't figure anything. Last time we did jumping and gravity, which was a pretty big step, and the one before that was a pretty big step as well. This is a small one. What we're doing this time is placing objects on the screen. We've slightly changed the build screen routine. The table now consists of. I've scrolled to it already. This is what a level looks like. You can. It's still very small. Nothing's changed. Basically, what we've added is we've added a type object. So next to horizontal lines and vertical lines, which have certain parameters, we now have objects, and objects are different. They can be player objects, it can be enemy objects, but I can also imagine that there will be like power-ups and weapons and bullets and that kind of thing. So these consist of an object indicator, which means that they can be handled differently. They have a character coordinate, just like the rest, and a type. So where in the previous versions we were looking at placing the player physically on the screen somewhere, we currently have a position, 5, 4, and a player type. So we can have only one player. But this would open the door, of course, to having 2 players as well, or even more if the Commodore could handle several joysticks. Enemies, locations, and that's it. So that's what we're doing, and let's have a look at what else is new. Nothing new in the game variables. Basically, everything is the same except this one. We now keep a table for active sprites. So even though, and this is a decision to do it this way. Again, we have tables for almost everything that we keep track of. This information is also present in in one of the registers of the VIC chip. But we keep our own table as well. So we keep 2 tables. We could save a little bit of space. It's still 8 bytes here that we could save. But that's it's a way to go. These are initialized at 0, and we basically what we do. We can use any of these sprites. The Commodore has 8 sprites. We can use any of them as long as we keep track which sprite is showing which shape and what their meaning is. We can do anything we like. So basically what we do is we scan this table for the first empty sprite slot, and we plunk the sprite shape data in here, which means the value that is multiplied by 64, so that the VIC knows where the sprite shape data is. That's the number that goes in there, and that's a reason to have this table immediately, as I discover as we go, is because the VIC itself only knows which sprite number is active and which isn't, and we keep actual data. Or is that true? I don't know, actually. I don't know. I think the VIC keeps a byte with a bit for each sprite that is active, and these puppies keep a value that points to the shape. But how do we tell the evict that. Forgotten. Anyway, this is how it works now. Let's look at build screen. Going to build screen. We no longer place the player. I'm scrolling down. And in this loop, this is the level data loop. This is where we recognize the end of the table or horizontal and vertical lines. And we now look for objects as well. We test for an object. If we find this is just a constant. It's 3. So if we find the number 3, then we'll know it's an object. And we go to the to this subroutine. We get the X position, we get the Y position, and we get the type. And then here's a function that says we'll find the first empty sprite slot. So the first sprite that is unused. And I'm guessing because parameter 3 has the type. Let's see what happens in find empty sprite slot. We go to declaration. Does it? Okay. Basically what it does, it goes through the sprite active table. If it's 0, then we have an unused slot, and we return with the accumulator set to 1. And otherwise we increase X, and if we're at 8, then and it's still 0, we haven't found anything. So basically this routine returns 0 when it's found a slot, and or it returns 1 when it's found a slot and 0 when it hasn't. And I think X is an index to the place where to the empty place. So let's go back to the object function. Parameter 3 was the type. That's funny because it was a type, right? So it's enemy, and we put that in the sprite active table. That's what we do. Then we calculate the position. We enable that sprite. We tell the Vic to enable that sprite. And we get the sprite player shape, which was 64. And we store that in the sprite pointer base plus X. And X was still pointing to the empty place. Okay. Am I reading that right? So that would mean, that's correct, of course, because that says in that place we put that number that we multiply by 64. And it's always the sprite player shape in this case. I can imagine that as we get more sprite shapes, we have to select the correct shape to put there. So this is going to do... Well, I know this is we're gonna see that when we start doing animation as well. But all the objects are gonna look like the sprite player because that's probably the only sprite shape that we have. So back to the build, to the object routine. We find an empty sprite slot. Well, we've done that, activated. So that's just basically it's there. Where does it get the X and Y position? Where does it put the X and Y positions for that sprite? So that must happen in this. Let's go there. X extend. Oh, right, here we go. This is where, okay, so this says this function is called calculate sprite position from character position, but it doesn't only calculate that, it sets them directly. Oh, so, there it goes, sets them directly. So it does all that. So and that's it. That's all there is in this version. So let's have a look at what it looks like. And there it is. There it is. This is our player. We're still our player. Still, I think that little bug that we found is still in there. I had a good tip from someone who said, "Well, just we'll try that in a minute." But you can see what's more important. What you can see is that there are 2 enemies now, and I cannot interact with them. So there's only collision detection for me in the background. I can jump, but I can't interact, and they look like me. And what I've also found is that they have different colors, but I believe that each sprite has a different default color, so we have to set the color. But we have some shapes to start setting as well. So, but let's have a look. I think. Oh, there I go again. I'm always touching my microphone to the. Sorry. Player movement, player control. Let's go to player control. Player is jumping. I think that was it. Player is jumping. Here we go. Jump on. A player jump table. Branch equals 0. Jump complete. We load X. Oh, increase. Okay, turn these around. So we first load and then increase. I'm not sure if we have to load it again, though, because we're comparing it here. I think let's just, let's try this. Make this a comment and then use it down here. Let's see if our jump range increases that way. No, it doesn't. No, it doesn't. Oh, wait a minute. Maybe the table has changed. Player jump position and increase the go to there. No, that's the size. Is that what I wanted? Player control. Let's see. Player's jumping. Right. We load the player jump position and we increase it. Branch not equal. Then we go to jump on. We load that. Plus X. Oh, wait a minute. Position. Okay. Yeah. Player jump table. It should do that. Should do that one first. I think in my what I did after I finished the video, I did this, which is less elegant, but it did work. The jump table size, change it to 11 because I've increased it by 1. I run that. You can see that but there was a weird hop at the end. Oh, there we go. See, pew pew. I've increased the jump size. Now I can jump up on this. I think this is what it was meant to do. See, my jump has increased now. I can jump up on this ledge now. So there's something there. And but I did think player control. Oh, I think player control. If I just players jumping, I can't see. Fall, not jump, stop, jump, complete, not. It's quicker to do this. Why is players jumping? There we go. The problem was that if I start with increasing, maybe it's not 0. Player is jumping. Player jump position. Player is jumping. We go players jumping. We load. It should do the compare. I don't know. This works. Anyway, any change that I apply now is going to be overwritten when I install the next step. But anyway, that wasn't really the point of the whole video. It's going to be a short one, I think. Yeah, it's 15 minutes. The objects. We've placed objects, so I'm curious to see what's going to come next. We may start picking them up. We may start to see some collision detection between the player and the enemy. So I'm excited. I like it. I'm at a point now where I can start thinking of, what would I do if I had the code finished. What kind of game could I make just with what you see now? With what you have now, you could almost make a game, but I just need a little bit more, like touching, collision detection, point scoring, that kind of thing. But this is sort of an empty canvas, like a template. You can start making things. So, anyway, thanks for watching, and I'll see you in part 9. Bye bye.